Okay, so we're ready to go, which is awesome, finally. Okay, I'm here to talk with you about two major ideas. Now, I know the talk is called Jenny, and it's actually about a project, which is called, surprisingly enough, Jenny, which arises from my need to actually be able to do some stuff faster than I was able to do with Jenkinsfile. And I'm only here to sell you two ideas. I don't have nothing to sell you of, I'm not gaining anything from those ideas. The first idea is how you're supposed to iterate in development. What would be the best approach when you're actually, when you're starting a new pipeline? How do you actually approach this? How do you iterate over this? This is what's Jenny about. So in the first part, I'm going to present you what Jenny is, how it came to be, what it does, what are the cool things you can actually do with it. And in the second one, even if you'll end up not using Jenny, I'm trying to convince you what are the best ways to create your build systems end-to-end. What makes a build system great, right? How you define it, how do you measure it, how do you actually give that build forward to your team? So, quick introduction, this is me, this is my Twitter handle, I have an email address apparently, and that's the Jenny GitHub address if you want to check it out. Now, I'm going to start, as I said, with an overview on why I needed to create this thing called Jenny. So this project, why does it exist? What was the problem with Jenkins, right? That I ended up writing my own thing instead of, why not, write a plugin or do some other whatever contraption. Then what is Jenny? What exactly is it? We're going to actually go in nuts and bolts and see a small demo on it. Then we're going to talk about build systems and how they evolved in time. Like we didn't just end up in this moment in time in Jenkins, right? It wasn't like nothing, like there was no past, and suddenly now we have Jenkins, and we're building pipelines, right? So we ended up somehow in creating pipelines and considering them the way forward, right? Why is that? Maybe there are other ways out there to make even better build systems, right? Is the pipeline the right answer? I will try to argue yes, and why. Also, we're going to go in details on that, and we'll have a demo in the second part where I'm going to show you, I hope I also gather your enthusiasm on that, how to actually get real nice build systems where you can, again, you can reason about what they do. This is very important. You can reason about what they do, and you can actually give them to your team or to other people, and they can also reason about and maintain them easy. So let's start with why. What were the problems with Jenkins, at least that I faced, and I think most people faced? If you use pipelines, so assuming you're using pipelines, if you're using plugins, it's even worse, because in plugins, you actually have to maintain and update them manually. But if you're using pipeline alone, what you have to do is, you would have to do for every change in your build system, you would have to do actual commits. You have to change the Jenkins file, right? Commit it, push it, see if stuff breaks. If it's not, you actually check the logs, you rechange it, you push it, you forget the semicolon once or a comma, you rage, you commit, you push. This is the workflow, right? This is how you work. And this becomes a problem pretty fast. What if you have multiple branches? Well, right now I'm on a checked branch, right? Checked out branch, I'm doing a change. And I'm iterating like this like crazy, and I'm wasting so much time. I'm just refreshing Jenkins, waiting for it to wake up from the dead and pick up my build and actually, checking the logs. Very annoying experience. At least for me, it was very frustrating. It also happened in a time when Docker appeared, right? And I noticed, well, I can actually move most of my builds in a Docker section. I can actually have most of my build being just section, a shell script where I just run the Docker thing, and then another section where I just run another Docker thing, and that's it. And I don't have any dependencies on Jenkins plugins. Everything is manageable. I just update and I just change, and it just makes a lot of sense. And then I also realized, hey, in Jenkins there is this great concept of Jenkins libraries. Now, in case you don't, who knows what a Jenkins library is first? The groovy things you put in, like new commands. Shared library, they're called. OK, I call them Jenkins libraries, sorry. OK, these ones, in case you don't know, there were a few, like a third of you don't know what they are. we're also going to see them in the demo. You can actually extend the language of the Jenkins file. You can actually add new functions in there with a very easy syntax. It's very, very easy to create a new element in this DSL in the Jenkins file where you can do your own thing. So for example, you can actually, and in these commands, you can use whatever other primitives from Jenkins you have. So you can have, instead of allocating a node and running a shell, and in there you run some, I don't know what command, you create something like compile this. And this will do the node allocation, you know, the Docker execution, the command, so on and so forth, the shell, etc. But the problem with this, it has the same problem. You have to do commits, you know, and Jenkins has to pull them. And you have to basically track. Now you have two dependencies you're running in parallel, right? On one hand, you have this extra DSL you're changing in the library, but you also have your project, which you're trying to make work, right? Because they're actually tied together. They're not like disconnected systems. So now what I ended up doing was I was actually committing in two projects and doing builds. And you know, I'm not very happy when I have to do that. Let me put it like that, right? It was very heavy to operate locally. I mean, I will show it in a demo how I'm running it now with the Docker Compose. If you are interested, I can also upload this into a GitHub if you want to play with them. But it's actually very tough. You actually need a Jenkins instance. You need a Git server, right, where you're actually pushing that. And your Jenkins has to be configured to fetch, you know, the data from the Git. Oh my God, this is like, sorry, for me, this is unbelievable effort for a stupid project that I have, you know, like, I don't know, a very tiny project, right? I want to have just the build. And wait, no, I have to install a Git server. I have to install a MySQL server for the Git server to actually have something to run with. And I also have to install Jenkins, tie everyone together, have a project, just to do changes locally. Have I lost my mind, or this is like a bit too much work to do anything, right? And despite that, it will take a lot of memory to use. Like even to have it in memory, it will actually be insane how much memory. Like to me, again, I'm very conservative, but to have a few gigs of RAM, just to have Jenkins up so I can run the build locally. Come on, I mean, yeah. And the other thing is you don't actually have fine control on the execution. At least, I don't know now, they said you can restart after a stage. But in reality, if there is a build, right, let's go back a bit what the build systems are. I want to build a project. I want to build some software, right? And I want to build it from scratch. I have the sources. This is my input. And my output, it has to be the artifact, right? That's what I want to do. I configured this beautiful pipeline, and I put a lot of effort into it on how to build that stuff. I describe in there, in containers, what dependencies do you need to actually build it? What programs do you need to install it, right? This is what you do in a Jenkins file. You're actually specifying all the dependencies you need to get from the source files you're having in the repository to the final artifact, and eventually how to deploy it remotely. This is what you're doing in the Jenkins file. You're defining the pipeline, how your software gets built. But when you're developing locally, you have to redo that pipeline somehow manually. You have to install that software manually. You would have to check in, you know, to see what versions of wherever projects you have, right? I'm running Maven, whatever version. I'm running Java, whatever version. You would have to install them locally and run these steps manually. And then I had this idea, like, why this doesn't make any sense? Why do I have two different systems, first of all? Why do I have a development system and I can't run my pipeline, which is right there, describing everything? And then I realized, you know, well, actually, Docker and Jenkins, I mean, the pipeline language itself, it can be very huge, especially if you use plugins. But if you don't use plugins, like I wasn't, you're actually using like 10 commands or something like that. Stage, node, sh, archive. I don't know, I'm trying to come up with more, but it's very difficult. JUnit, archival, right? You're not actually using so many commands. If you actually refrain yourself, okay, I'm going to put every single plugin I can find under the sun. And what this leads to, it leaves you with a Jenkins file, with a pipeline, which doesn't depend on anything in Jenkins. It describes your build end-to-end, but doesn't depend on anything on Jenkins. So what is Jenny? Have you noticed I made a name with bold, you know, like Jen? I needed something to start like Jenkins, right? So the first thing which came to my mind with Jen would be Jenny. And it also helped because a friend of mine has a daughter called Jenny, and he's part of the Germanium thing. So, okay, perfect. You know, this is a hit for everyone. So if you notice, a Jenkins file is actually just a Groovy script. And the commands themselves, like stage and node and so on and so forth, they're being interpreted by the Jenkins server. So then I decided, hey, you know what? I'm going to just make a Jenkins file executor. I'm going to create a Groovy shell script. I'm going to provide some implementations for the commands from from Jenkins, and they're just going to run locally on my system. Since everything actually runs in Docker, I still have this awesome stability of my pipeline, right? And I don't need the whole Jenkins to run. So this is not a Jenkins fork. This is just a bunch of Groovy scripts, which they're actually just stitching together the Jenkins file so we can actually execute it. It has basic pipeline step support, and I'm going to go on the next slide and show you a few of them. It has more than what you see in the slide. They're also written in the README, which I actually had time to implement. It's also targeted at what I use. If you have missing features, feel free to open PRs or just say, hey, I want this. I will try to implement them if I have time. And also, what's very important for me, it's very lightweight. So it doesn't have a real installation. All you do is you check out Jenny, you put it in the path, and it should work. This is a Groovy script. It depends on some Java libraries, but it will fetch them. So there is like some vgets in there, but that'll be it. There's a wrapper to actually fetch those. And it's not intended for production. The reason why I'm saying this very explicitly, I had a friend, you should try to go to the conference and tell them, hey, push it to production. No, it's meant for you to debug locally. I'm not trying to be 100% compatible with Jenkins. It's not on my roadmap. It's not, I had issues with Jenkins. I'm not trying to redo Jenkins in my Groovy scripts. Not going to happen. So let's go on support, what it actually supports. It supports, as I said, the basic commands which you would expect. There are some differences, which in my opinion are pretty awesome. But one of them is checkout SEM, which just copies the files. Why this is pretty awesome? It's because when you're actually running the build, right, when you do a Jenkins pipeline, you can change multiple files without committing them. And for the checkout SEM, because it will just copy those files into that folder, it will just copy in a TMP folder it will create for the node. What's going to happen is you can change your Docker files, you can change your Jenkins file, you can change some, I don't know, Webpack, God knows what, and you can change all of them together, and you can try out and iterate much faster. I told you one of the biggest problems in Jenkins was, I think it still is, you have to commit everything, right? You always have to commit. You do a change, commit, see what happens. OK, this doesn't work. No, change, commit, see what happens. With this one, you don't need to do that. You actually just run it locally. Parallel is also not really parallel. That's not because it's hard to implement a parallel executor in Groovy, because you just have the Java underlying, and there is a fork join pool. So I could just literally throw all the jobs in a parallel executor. The only problem is, again, this is not intended for production, and you wouldn't be able to read the logs. Everything would just output on your console from every single parallel build. You won't understand what the heck is going on. So the point for this one is to just be able to run them locally and to be able to choose what you want to run. It also supports nested builds. This is a feature which, I'm using. So you can actually fire up from a pipeline another build into Jenkins, and it will wait for it to finish. It supports build parameters. So in case you're using build parameters in your Jenkins files, I don't know if you know, you can actually put you can put the build parameter section at the beginning of your Jenkins files, and this is going to change the configuration of your build. And the next time you'll run it, you'll have the opportunity of filling in those parameters, right? And this is great because then you can do conditional execution. You can do something like, OK, if this flag is checked, then I'm not going to execute this, I don't know what. Or you're going to inject something into the environment, so on and so forth. And it also supports Jenkins shared libraries, which is basically to extend the vocabulary of the pipeline. So this being said, we're going now to the first demo. So this is the first idea I'm trying to tell, which I think is awesome, which is Jenny itself. In here, I created, as I said, the Docker Compose for the infra. So this one, it's actually going to bring up a GOGS server, Jenkins, and the MySQL. So I can just show you the Docker Compose. This is running my own Jenkins. Jenkins itself, I'm actually building it because I want to have Docker available, this is the only thing I have, and like a few plugins extra, like Blue Ocean. I started at the time when Blue Ocean was not packaged by default. I don't know if now it's packaged by default, if I would just pull Jenkins. But feel free, try out with something else. It doesn't have to be this one. Another thing which I do is I'm putting in the Docker socket. The reason is the container itself is going to be a sibling of the actual builds which are going to run. So if I'm going to run like another Docker build whatever, Docker execute whatever, I'm not running Docker in Docker. I heard horror stories about data corruption. I don't want to see if they're true. This is like, honestly, because otherwise it would be easier to just install Docker. It's actually easier to just install Docker because implicitly it will have the local installation local, and it will just try to spin them off inside that container. Then there's Gogs, which is a very nice Git server. And then there is MySQL, very secure, as you can obviously see. And this is a play environment, don't. So let's bring it up. OK, this is going to bring up the Gogs, MySQL, and the Jenkins. Now, I've also created some projects in here. One of them is a shared library. And the other one is the Jenkins Demo, which is basically this. The Jenkins Demo is an application, a Python one, which basically just displays hello world, something like that. Not really, I think it's hello Jenkins Demo. So let's see what it does. OK, so this is what it does. Now, I created a Jenkins file in here, which it has a Boolean flag, which allows me to say if I want to run the static checks or not. Now, a great thing about Jenkinsian pipelines is that you can actually build for wherever platform you want, right? If it's Java or if it's Python or Node, or you can actually just put a bunch of stages. And my personal belief is that in the first stage, you should actually just build your tooling. In this case, I'm actually cheating, and I'm doing two things at once. I'm first building my Python 3 tooling, which is a container also here. So let me show you this one. So this one just has the tools I need to run my Python things, so mypy and PyInstaller. And in here, it's going to run the static type checks to see if the application actually still compiles. And in there, it's actually, in the next stage, it's going to run the pinstaller, and afterwards, it's going to archive the artifact. Basic build, nothing super fancy. But what's nice now, we can run it with Jenny. So we can do, for example, Jenny. There is also a flag called -i from info, which will show us what can be run. And this one will actually show us, OK, it's going to run first the stage type checks, and then we will allocate the node, it will run delete there. This also, in this case, because I'm actually deleting files on the host, I'm putting the folder, because in case there is a bug, you might want to see, I'm not deleting your home folder, and yeah, that would suck. And then building this Docker image, and then inside this Docker image, I'm going to run a shell script, and then in the second stage, basically what you've seen in a more condensed form. Now, we can also pick what we want to run. So for example, we can just pick, OK, I want to run only the first stage. So I can say only the first stage. And this is being defined by the, by the stuff you see in here in the square brackets. I'm actually allocating some identifiers. And then you can actually specify what exactly you want to run from that build. Because in a lot of cases, if there is stuff like I want to publish to production, right, that will be the last stage. Because this is what runs on the real Jenkins. You probably don't want to run that locally. So then you can skip them. So in here, you can also do with -skip. So for example, I'm going to skip now the stage 1 and run it. This one actually ran it, by the way. So this one, what you saw, I didn't run the -info. So this one actually ran it. So the way this one works is, as you can probably already imagine, it just takes the commands and just redefines them. And why this is great, this is the demo I want to show you next, is because you can go in a folder. I don't know, let's make it your X. OK, apparently we're right there, really. Why? Seriously? I'm in my local folder. OK, this one, let's go to the real TMP. So we're going to make a folder X. we're going to write a Jenkins file, and I'm going to make a mistake in it on purpose. Let me, I want to see if any one of you actually sees it. So test. We're going to allocate a node. Labels are not being used, so it doesn't matter. You can put them, but nothing happens. And then in here, we're going to just do sh, and then we're going to cat the Jenkins file. Now, surprisingly enough, this is not going to work. You know why? I didn't check out the project. So the actual node you're going to see in there, right? If I would check in this one and try to put it into a project, actually, you can do that, right? We should have the gogs up now. So let me go to, So I'm going to go to my gogs local installation. Okay, and log in. Okay, logged in. I'm going to create a new repository for X, of course. Repository is public. Fine, create. Great, we already have this repository. So let's do a git init. Okay, so now we pushed it. We have a new repository. We go to Jenkins. Let's get the HTTP one. We're going to create a new multi-stage pipeline. Multi-branch, sorry. So go this. Okay. Seriously? Okay, apparently I double-clicked it or something. Okay, so let's configure. I'm going to add the git source, basically, and that's about it. We're going to try to run it. I'm not going to use pipe. I already defined a global pipeline library, which is the one I'm going to show you next. So in here, branch sources, just a basic git. The repository should be this, except that this is actually like this. They're running in the same compose environment, so they will actually be able to see each other, but the ports, they're actually not mapped correctly because the 3000 somehow doesn't get exported. No idea, don't have time. But it should work. So let's try to apply. That should actually be enough. So this one should already start the build, and this one should fail because, surprise, surprise, there is no Jenkins. And this was the experience I had before, right? This is, and if I would even hear Jenny, I would actually get the same stuff. There is no Jenkins file when I'm trying to run it. So yeah, what. So in here, I can go now into the checkout. Run the Jenny again without actually committing, because that's the point of it. And surprise, surprise, this one actually worked. It actually cat the whole thing. This is why we see it in here again. And then we do the commit. Actually, let me put also webhook. Copy, go to here, settings, webhooks, and so I'm going to add a webhook, so whenever I push, it will immediately trigger the build. It's one of the first thing I do because otherwise I always have to remember and click, run, super annoying. So git push, okay, git commit, fix bug. Okay, and this one should already trigger the build. Okay, it was already successful, as you can notice, and yeah. So this is basically what Jenny is supposed to do. And it also has, as I said, this, in my opinion, sweet features where you can actually go and define in the Jenkins world, in the Jenkins Demo, you can define stuff like what libraries are allowed, and from the libraries, if they define commands, what commands should be evaluated for info. The reason is, I don't know if commands have side effects. If you're removing containers, right, or if you're deleting some I don't know what, and you do that programmatically in your own shared library, I don't want to run it from your local instance. I'm scared. You have to be responsible enough to say, okay, this one doesn't actually have side effects, or you can just go into it, nothing will happen. So in here, this is actually a regular expression, but you have to say, okay, I can run anything which starts with Python. This is what you basically see in here. And the library itself, you can just point to another folder, which in my case is the Jenkins library in here. And to create a shared library, it's very easy. You can just define this command called Python static check, right, like this. As I said, it just runs sh and mypy. You can also make it to go to source. Oops. And then when we go to our build in the demo, in the Jenkins file, we already ran that build. Did we run the build actually for this one? I don't remember. No? We did, or? Okay, let's run it then for the Jenkins demo. Oops. So I'm going to run it with Jenny. This one is just going to run the mypy on the current project. And then it's going to run the PyInstaller to get the binary out. And then the current binary will also be archived. This will take a few seconds. A few more seconds. And ta-da, surprise. Now, what happened was actually we have a binary in Jenny workspace. It was, I'm actually using it for my stuff as well. This is why you see all the other projects in there. Workspace, and then archive. And if we're running it, it is not a file, okay? Because it's /tmp, sorry. It's not /. And ta-da, but this is actually a standalone application which was built in the Docker container, which contains the Python environment with it, right? So if I'm actually LSing this file, this is like 10 megabytes, So this one actually has the Python runtime bundled in the application itself. So I can redistribute this application on any machine which has a normal libc, which would be any Ubuntu 16.04 and plus. Good, so this is the first part. You can actually run Jenny to iterate much, much faster on your builds. You change stuff locally, you change in the Docker file, you change in the pipeline, you just rerun it until you get it run correctly. And afterwards, what do you do next, right? How do you define a good build? Is this, for example, a good build, the one we just saw? Tough question. This one has only 2 stages. Right? I saw someone doing it. I don't know, like, why you're asking me? This is a valid question. How do you evaluate if this is a good build or not, right? How would you make your pipelines absolutely awesome? So when someone sees it, you know what? I want to make it exactly like that. I don't want, this fake mumbo jumbo like this I cannot understand and maintain. I want something which actually makes sense. So this is the next idea I want to show you. If you remember, you can actually change using the shared libraries from Jenkins. You can change the DSL. So in here, instead of this sh, we can use now this other command called Python, wherever I named it. I'm going to see in a second. It was Python static check, I think. Yeah. So in here, we can run Python static check instead of the sh, right? We don't have to write, that sh and voodoo cryptic stuff. We can actually define better vocabulary. It still does the same thing, but we can define better vocabulary what it does in the context of our application. So what we're moving away from, a bunch of shell commands and blah, and we're describing what the build does in our own language, which makes it already a bit cleaner. I still don't like writing Docker build and stuff like that. So, okay, this is my runtime. If we're running now Jenny and inspect and so on, so to see what exactly is going on, it's actually the same, right? Inside this, we're just running sh, right? Somehow, because what happens is there are only the commands from Jenkins which are actually being executing and changing things. Everything else, like the groovy stuff and so on and so forth, you can have as much as you want, as long as it doesn't really run an SH, or it won't have any side effect, unless you start creating files directly in Java, in the groovy script. But it won't have side effects. What you need to do in the end is to use these low-level primitives. But the whole point of this shared library is you can actually abstract on top of it, and you can write like a human being, and you can actually see in the end your pipeline, what it does in human terms. You don't have these super cryptic commands which you don't understand. I mean, I don't understand what they're doing, right? I see some super cryptic SH command piped into some God knows what. How am I supposed to reason about it, what it does, right? If something doesn't work, what is my next step? Am I going to try to decipher? At least tell me what it's supposed to do. And one option is you either start writing like a bunch of commands, so your Jenkins file becomes super documented in itself. You have like comment after comment after comment, or what I would recommend is you move away the most common stuff out. And you can even do stuff, I'm going to show you this. This is actual stuff that I'm using, where you move away even more complex commands which are already in Jenkins. So for example, Jenkins has this docker.build.inside. And the problem with that is you can only have two parameters. The first one is the tag name in the Docker build. The second one is every single other command parameter you'll pass to the Docker. So what happens is you'll have Docker build, tag name, a single tag. You cannot pass multiple tags. I don't know why. And then you end up with a huge line specifying every single argument and environment you're passing to that Docker build. Or you would start doing like plus in the Jenkins file. And what you can do with that is you can actually go and extend the vocabulary. So you can have a Docker build command where you will just concatenate the string for yourself, but you'll actually call it the Docker build with parameters. I'm going to have like a file. I'm going to have build arguments. I'm going to have tags, so on and so forth. So when I'm actually calling it in my stuff, it would be something like Germanium. Oop. I'm just going to pick some Germanium stuff wherever it is. I think Germanium itself will do. You have something like this. Instead of a huge string, with docker.image and then image name and then .inside, and then in this inside call will be a huge, huge string. I can actually pass multiple parameters. I can structure them differently, and I can even leverage the vocabulary I'm using for simple stuff. Now, this is the first thing. You can extend the vocabulary to make simple things. You can use Jenny for that to iterate much, much faster. Let me go now to the next idea of the presentation, which is build systems. So how we ended up with Jenkins. What was before Jenkins? Well, before Jenkins, if you want, you can consider Docker a build system, which in a way was like before Jenkins, where you would just run shell scripts, right? If you think about it, what is Docker with on-build and arguments? It's just a shell script aggregator, right? You just have a core image, which defines you the environment, and then with the on-build, you're defining what other commands are going to be executed in the next image when you construct your application, right? So you would have shell scripts and just basic, a very basic set of commands you would run to build your application. This would be one thing. In JavaScript, you have a bunch of build systems out there, but they're all reduced to one thing. They're executing a bunch of tasks. I mean, at least grunt and gulp, except Webpack. And you define something like this. I have a task which is, compile this JavaScript into this other form of JavaScript, or TypeScript into this JavaScript, or Sass into this CSS. And this one actually depends on, so my JavaScript compilation depends on some, I don't know what, template processing, which in turn depends on some other thing. And the default, which would be the actual build, depends on everyone. So what's going to happen was when you start the build, it will start analyzing what steps are supposed to be. It will flatten this out in a huge list, in the case of grunt, and start running them one after the other. If you'd use gulp, it will run them asynchronously, but it's literally the same thing, but far more complicated. Webpack, it's a bit different, but it's actually a single step in this process where it's just taking the sources out, you define all the dependencies you have, it builds the graph of all the components, how they depend, and it generates a single file out. Java came with an awesome thing, which is the Maven pipeline. So Ant and Gradle, they're also this approach where you just define tasks one after the other, right? But Maven came with a pipeline, right? Think about it. There was a pipeline before the Jenkins pipelines. Now, question, would this pipeline be able to do me what Jenkins actually does extra, which is the deploys? The answer is yes. Surprisingly enough, Maven defined years ago, before Jenkins really had a chance to be used, en masse for production, stuff like that, defined a deploy part in its phase. So first of all, they call them differently. They will call them the life cycles. So the pipeline is actually called a life cycle, and they would have phases, which are places where you can inject specific tasks, where you can do other things. And you would have generate sources, compile, test, package, install, deploy. If you remember in our pipeline, doesn't it look similar a bit? Wasn't it a bit strange that we had static type checking? Isn't this like compiling in a way? If we would have TypeScript, isn't this similar when we're cross-compiling it? What is the difference? What makes Jenkinsfile, right, a better approach? What is the difference? I would argue even Jenkins, because it was able to have a Maven build and post-process actions, which would be the actual deployments, was a sort of a very simplistic pipeline. We wouldn't call it pipeline. We didn't have the term defined. Pipelines, they became defined when we saw the Jenkins files and people told us these are pipelines, right? But we used a sort of pipeline, not, again, mentally visualizing it as such, where we would just run tasks one after the other. So then how can we make our build, again, amazing? How can we get this pipeline, which is very fuzzy right now, and we can make it look good? Well, one problem is we don't have them standardized. I just created a pipeline in here, right, where I just threw in some steps, and there is no way for you to reuse it, right? For example, I have this Jenkins file right now, and you can use it to compile a Python application. So if you have a Python application right now, and you want to have it an executable out, you could use my pipeline, right? Yes, you can just you have to copy it, right? And it should work out of the box. I don't have any specific thing in there, any plugin in Jenkins, which you would need to install. I don't have some, I don't know what, funky dependency. You can just take it and use it in your project. So what stops you, right? What stops you in just taking that Jenkins file and using it? Well, one thing is, if you would have like 10 projects, not one, you would have to copy it in 10 projects, right? And this becomes a hassle. How the heck do you maintain 10 projects of very different Jenkins files? And each one of them, they can have branches which change, and then in them, you would have to maintain those Jenkins files as well, right? It becomes immediately impossible to maintain. So if you remember, there was a very cool concept, which is called shared Jenkins libraries. What if you can just move the whole pipeline into a shared library, right? What if you do that? Then you can get into some really cool stuff. First of all, you can actually move the whole logic of the pipeline in there. So I'm going to show you one example, which I'm actually using, which is the Germanium build system pipeline. And this is where I want to convince you on the next thing, to use this kind of pipelines, the programmatic pipelines, and to reuse them in the shared library. This is, in my opinion, the highlight of this talk. If it's anything you remember, like everything will be a blur with the Jenny and all the parameters, remember this. You can take the pipeline, move it out in a shared library, unify across your organization, across all the projects of the same type, what are the steps which are needed to be built, right? And then as you expand your stuff, you can just add parameters. This is just a function. It's basic code reuse. If you would program, right, anything, you would think about it, well, how can I reuse my code? What is the holy grail of Docker build files? The one-line Docker build, where you do from blah, and everything else happens magically, right? This is what we're aiming for. We want to have a build system which is somehow smart enough for any kind of Python application in that range in our organization, right, which will just work. I'm just going to say, from whatever organization name /Python, wherever, build system, and it will just work. It will know from the project structure. All of these are already standardized. Most companies, they have this standardized. You have the source in this one place, you have so on and so forth. But then your builds become, so first of all, as I said, since you can use anything in there, your builds will become, 1 second. Any of these will do, but I'm going to go with the Python. This is what my Python is. And this is my build system for it. That's it. Right? This is my build system to build all the Python images that I have, to publish them in my local Docker registry, right? Look how easy it is. Can you understand what it does? Of course. You look at it and you immediately understand what it does. If you would run it, you would also see it how every single stage gets applied. You can also change later stuff like how parallel it is, what kind of nodes you want, and so on and so forth. If I want, for example, another system where I have a variation, I will just have in here a parameter. For example, skip wherever tests, because they are not implemented for this one project, right? So across the organization, we'll go, OK, we're going to test now all the Docker containers, right? So we're going to introduce this stage in this shared library. So every one of them will actually start running it. But because this one project does not yet support it, and we will need like 2 weeks to implement it, we can just add a parameter in the shared plugin, right? Where we say, you know what, if this skips test equals true, we're not going to run this one stage. And it's easy, right? It makes sense. Everything is just pieces falling into place. And to me, this was the one kind of aha moment when I realized, you know what, I can have all my Docker files describing me the infrastructure. And I can have the Jenkins files alone describing me how my software gets built end to end. I describe everything that I want to use, all the tooling that it's needed in the Docker files in the first stage of my build. There is no dependency on Jenkins. I have a single dependency on Jenkins, which is the ASCII color, because I really love colored logs. This is a weakness of mine. Yeah, it has to be there. Anything else, there is no other plugin. I don't have any other plugin. Everything is running there. If I have a publishing thing, I'm supposed to deploy it to Amazon. I've implemented at the company I'm working on 2 builds for different things. One of them is a TypeScript application, which gets deployed into an S3 bucket. The other one is a Python application which gets deployed in Elastic Beanstalk. Completely different builds, the same idea. You can formalize this. The first one is build the tooling. The next one is build the pipeline. So since I'm running out of time, what are my conclusions for you to get something to go home with? Don't use plugins. Why? Because your Jenkins file should describe your build system. It shouldn't be the configuration of your Jenkins. I know I might gonna get into some angry people in here. Well, we do have configuration as probably you shouldn't. You should have the whole thing described in the Jenkins file, and the Docker file should describe whatever other tooling you need. You should use libraries to move your pipelines into the libraries and reuse them across the projects of the same type. You don't have to be constrained of a specific type, but you have to define what it is, that type. And if you need whatever other extra steps, you can add them later, which is great, and it will apply across all the projects you have. And then you should strive, this is, again, to a single line Jenkins file. This is the same thing which we talked about when we came to Docker. This is, in my opinion, the holy grail of the build systems. The end. Questions? No. I'm not sure if I will have 2 minutes, right? So we have 2 minutes. Questions. Feel free to ask about anything. Go. Of course. Yeah, I wouldn't. Yeah, that would be really, what? Yeah, it is on GitHub. Yes. It's working only on Linux and Mac OS. Yes. No. I mean, the thing is, look. Let's step back a bit, right? If you talk about, is Kubernetes part of the base pipeline steps? Probably not. If you need some sort of publishing, right? Why not just use kubectl? Why not put that one into a Jenkins library, right? Shared library, and just use that one. Just extend the DSL. You don't have to be constrained. I was actually using the Docker builds before I even knew there is existing a Docker command. I was just using the SH. And the commands you saw before, the docker build, blah, I was just using them with sh. I was concatenating the string, running sh, worked. Don't think in these terms of, the whole point is the whole pipeline should be describing how your software gets built, how it's getting published out. If you're already needing plugins to do, I don't know, all kinds of crazy integrations, unless it's for cool visualization, okay, this is my end time, whatever. Unless it's for some cool visualization of whatever reports, I wouldn't bother. It's just legacy you will have to maintain later. If they pull the plug on that plugin, what do? You're now stuck, right? You can't update it. I have security issues. Why? Because they're here and they're selling plugins, or I don't know. I don't know, honestly. I'm not trying to sell you anything. As I said, yeah. We're good? Awesome. Sorry.
Does Jenny support sequential stages?
Sorry?
Sequential stages?
Yes, of course. I just shown you, right? It also supports parallel stages, you mean, probably. Sorry?
But it's not really parallel?
No, it's not really parallel, but you can. It has a nice feature, which is not present in the Jenkins thing. No, in Jenkins. In Jenkins, it's not present. You can actually specify a branch which you want to run. So when you're going to run with -i, the parallel branches, they also get IDs. So you can actually specify, run me only this parallel branch. So if you're running, like I was, if you've seen, I'm running a bunch of fan-outs for the Docker builds. I want to specify, hey, I'll run me this Python 3 point wherever, right? Because I have some problems in there. But I still want my build to be generally parallel without having to comment every single parallel branch. Thank you. Awesome, good. Don't forget to vote, if you'd like to stuff. Say yes. Preferably yes, I mean.